Is it recording? Okay, it is recording now. Okay.
Yes.
Okay. So let me just full screen is I think, yeah. Okay. Um, okay. So as Professor PPD mentioned in the last class. So this is a course where you will sort of learn to engineer software, right? So how to how to make good software. So so there are many components of software engineering. Okay. Professor PPD mentioned that and it is also there. You can see the syllabus. In the syllabus, it is there. There is the component of software development, or if in our common language, if we say, it is basically the process of writing programs, right? So that is one component. Then there are so many other components, right? So when you are writing a software, one of the major components will be collection of requirements from the clients, the users of the software. Okay. Then there can be so collection of requirements, and then preparation of a document which sort of says what these requirements are. Okay. Then based on the requirements, there should be a hello. Okay. Yeah. So based on the requirements, then there can be a design. Okay. So you can have a very high level design of the software. What are the functionalities to be achieved? What part of those functionalities are to be so your software may have different components or modules. Uh, and there may also be modules which are not in software. So there can be hardware modules, and so on and so forth. So your software should work within kind of a ecosystem of all these things, right? So you need to do a high level design. Okay, so that is one thing. And then you need to do a low level design of the software components. Okay, so this is the other thing that you will learn a little bit in this course. Okay. um, and then there are two very important components. One is, I mean, both are related in some sense. So one is maintenance, and the other is testing of software. Okay, so both of these, again, you will learn towards the um, end of this particular course. But a large chunk of this course, we will focus on this software development part. Okay, so maybe next 5 or 6 weeks we will focus on this software development part. Okay. Now, obviously, you know how to write programs because you have already written some programs in your programming data structure course, right? So you have written some programs in C. Okay, so the question is, what is new, right? What is different? Okay, so the thing that is different is going to be different in the software development part here, is going to be that you are going to learn um, the procedure of breaking down very large programs into smaller programs. Okay, and then developing the small components of these programs, and then sort of having this large program. Okay, so that is something you may have done, or you may not have done in your PDS course, for example. Okay, so the complexity increases a lot. Okay, Now, so this is one part of the complexity, how complex the software is. Okay. The other part of the complexity is that in a real software development, you almost always never do the software development alone, right? So you do your software development along with your co-developers because it is too much work. And if just one person had to do the whole work, it will take an inordinate amount of time, right? So, uh, so there will be software architects or managers and so on and so forth. So they will kind of break down the whole software that needs to be developed into some modules and then maybe sub modules depending on how complex the software is. And then um, you will work on one part of one module maybe. Okay, so you will work on developing one part of one module. Okay, so in both these cases, okay, whether it is because of the complexity or because of the collaborative nature of development, okay, what is important is that you follow a style of programming. Okay, so that is the other thing. So you can achieve the functionality. I mean, you must have seen while writing C programs that people write very complicated ways of doing very simple things, like even swapping two variables can be done using very complicated codes. Okay, and that is a fun exercise to do. But what happens is that in a collaborative environment or in a real company, that is almost never a very good idea because other people will have to unnecessarily spend a lot of time trying to understand your program, and that is not a good idea. Okay, so you should always write the program in a manner which is not just understandable to you, but also it is very easily understandable to the other programmers who are working with you. Okay, so now how will you achieve this, right? So that means that there has to be a common programming style that all of you, so you and other programmers, you have to follow. Okay, so what are the programming styles? Now, I must say that this is the list that you see here is by no means like a exhaustive list. Okay, there are so many other styles that people have developed. Okay, so maybe in C.
Excuse me, sir.
Yes, yes.
So which screen are you sharing?
So are you able to see the software engineering uh, screen that I'm sharing?
Yes, sir.
Yes, sir. Now it is fine.
Oh, okay. So you were not seeing this earlier. Oh, so now are you able to see this?
Yes, sir.
Okay, something was happening. I don't know what was happening. Okay. Um, okay. So you can see the different programming paradigms that are there on the screen, right? So most probably what you have used in your PDS is what is called the procedural programming. Okay, so at a very high level, if I were to describe what will it be? It will be that you have the data and you have the procedures or the functions that work on this data. Okay, and so the data is stored either in variables or structures or arrays and so on and so forth. Okay, and the functions take as input some of these and produces some output, and then the procedures can be composed, so the functions can call other functions and so on and so forth, and then they can achieve kind of the functionality. So the procedures in a certain manner act on the data to achieve the functionality. So this is I am assuming this is a style of programming that all of you are familiar with. Okay. There is another style of programming which is called the functional programming. Okay. So what is the functional programming? There, the idea is that your functions and your data is again very separate. So even more separate than the procedural. So in procedural programming, sometimes based on the data, you will take your functions may call in different order and so on and so forth. So that can happen in functional programming also. But the key idea in functional programming is that what you do, you focus on the end goal or the end result that you want to achieve by composing different functions. Okay. So what the programming language will provide you is methods to compose different procedures to compose different functions. Okay. And then once you have, after composing these different functions, once you have achieved the desired functionality that you need, okay, you will feed the data into this composite function and you will get the desired output. So this is broadly, very broadly speaking, I mean, this is not exactly accurate, but very broadly speaking, this is the functional style of programming, and in certain settings, it works very well. Okay, so one very common setting being that when you are trying to query a database, for example. Okay, so there functional programming works very well. There are many other settings where it actually works very well. Now, the third style of programming that that we will follow, and that is mostly used for generic software development, is what is called the object-oriented style of programming. Okay, so what is the object-oriented style of programming? So here, like we discussed a bit, okay, data and the functions related to that data are grouped into what are called objects. So objects are kind of central to this object-oriented programming. Okay, and then you can create many different objects, and the idea is that these objects interact with each other, okay, to achieve the desired functionality. Okay, so so this is the key, the high level idea behind the object oriented programming. Okay. Okay. So like we so of all these programming paradigms, object oriented programming is, you can think, most suited for development of large and complex software systems. Okay, so that is why for generic programming, or not generic programming is a different term, but basically yeah, so for general purpose engineering of general purpose software systems, this is kind of one of the most popular ways of doing programming. Okay. Now, of course, needless to say that many popular programming languages like C++, Java, Python, etc. support this style of programming. So the thing to note is that object-oriented programming, I mean, the fact that you are using object-oriented programming does not mean that you are not using procedural programming. In fact, you are almost, I mean, almost every object-oriented program will have subparts which will use procedural style. Okay. Just that if you try to develop the whole program using a procedural style of programming, it may become too complex. Okay, so hence you go into this object-oriented style, and we will learn how to design and develop object-oriented programs. So as a consequence, you will see that all these languages, they support procedural programming, And many of these languages, to some extent, also support the functional style of programming. Okay, so and this is kind of evolving now. Earlier, they didn't support much functional style of programming, but recently, both C++, Java, and Python, all three, are supporting some features of functional programming languages. And yeah, there are also other languages like Scala, which are, which actually merge object-oriented programming and functional programming completely together. Okay, so, but the key idea is that these languages are also trying to also implement some key components or some highly used features of functional programming languages. Okay. Okay. Now, among these languages, C++, so all these languages are very popular. I mean, they're popular for different things, different reasons. Okay. C++ is popular because of some of these unique things which it offers. So one is that C++ is kind of an object-oriented programming language which can be used, seamlessly for system programming. Okay. So the other two are probably not that easy to use, although Java is also sometimes used in embedded programs and all, but probably not as seamless as C++. Okay. The other thing is that the programs that you write in C++ are very high performance. I mean, in the sense that so C++ is a compiled language. So you can compile and generate code which is basically like machine code basically. Okay. So that is the other reason why C++ is popular. Another reason why we study C++ here is that it is kind of a feature-rich language. So as you can understand, every programming language implements some some aspects of each of these programming paradigms, and then lets the programmer use these aspects to design his or her own program. Okay. So C++ is one of the languages which implements a lot of the aspects. Okay. And hence it's good for learning. So if you learn C++, okay, it will be very easy for you to learn Java and Python later. Okay. So that is the other reason. Okay. Now, so the reason C++ is sometimes not used is that, I mean, for smaller projects, for example, Python or Java programs can be much smaller and they can take much less time to develop compared to C++ programs. Okay. But yeah, so that is the whole idea. Now, here I am just mentioning some of the object-oriented programming concepts. Okay. You will not, so don't worry if you don't understand all of these concepts right now. That is not the intention here, but you should remember these concepts, and as and when you see those features, okay, you can just connect back to these concepts, how they are provided, how they are implemented, and how can you use them or take advantage of them to design your software. Okay. So first thing is objects and classes. So classes are basically types of objects, okay, which are defined by user. Okay, so almost every object-oriented programming languages provides. I mean, some users, provide support for these concepts. Okay, so okay. Then another concept is encapsulation or data hiding. Okay, where the idea is that the programming language provides support for this paradigm that data should be hidden inside objects and only access through member functions or methods. Okay. So this is called encapsulation or data hiding, and there are different ways that C++ provides this. We will see. Okay. Then there is composition. Okay, so objects can contain other objects. So objects can be composed together to form other objects. Okay, so again, most object-oriented programming languages provide this. Okay. Then there is inheritance. So objects can borrow properties of other objects. Okay, so this is again a key concept, and C++ provides it to a greater generality. Java provides, as you know, a little bit restricted inheritance, but it also provides, so almost all OOP languages provides this concept to some extent at least. Okay. And then there is polymorphism. Okay, so polymorphism is basically the facility that the language provides in different contexts. We will see what are the contexts where the function or the code that is executed depends on the type of the objects. Okay, so this is so these are some of the key OOP concepts we will see. Okay. Okay, so so this is a tentative list of features that we will cover in this course, or in this not course, but in this module of this course, which is part of the course, software engineering course, which is that. So we'll cover some procedural enhancements in C++ over C. Classes, obviously, overloading, inheritance, typecasting, exceptions, templates. So this is kind of a incomplete list, and it's a dynamic list. So I may introduce something more and remove something from this list. Okay. So before we go into C++, any questions up till now? Okay, so I just want to ask something. So can you please raise your hands? How many of you are familiar with C++ and object-oriented programming? I mean, you think, a little bit familiar with. I mean, nobody. I mean, you may not know the whole thing. That is fine. A little bit familiar with C++ and object-oriented programming.
Sir, I wanted to ask, will the theory classes be in progression with the lab classes? Because in lab we are having Java right now, and C++ comes a little later.
Yes. See, in Java, what we have done is we have asked to, to sort of maximize your learning. The way we have designed it is that there you will learn a little bit of Java. Okay, so we will not ask you to learn like the whole concept of Java. Okay. C++ we will cover in much more detail. Okay, like I mentioned that so it may be that, I mean, once you learn C++, learning Java in detail, learning the details of Java will be much easier for you. Okay. Having said that, the first assignment was, if you see, just so you have to learn a little bit of Java, and then you have to do some programming with that. Okay. Yeah. And then in the lab class, we will also learn, I mean, we will also do some programming with C++. Okay. And then we will also do some programming with Python. Okay. So Python part we will focus on more. Okay. But in the theory part, we will delve a little deeper into the C++, The reason we are going into one particular language is that, you know, all these concepts are pretty general. So object-oriented programming can be done in all three languages. Okay, but it is very difficult to discuss and, you know, communicate the concepts unless you are talking about something specific. And that specific thing we have chosen is the C++ thing, because you know, we feel that it is kind of I mean, like the feature rich thing, that if you learn the concepts that are implemented in C++, there will be some concepts which will not be there. Okay, but those are probably a minor subset. Okay. So the answer, so does that answer your question? So it will not be like whatever you are getting, you know, we are teaching in this class, in the theory class, the exact same thing you will go and implement in the lab class. It is not like that. It is, the lab class is a bit complementary and hands-on towards, you know, you learning to program more. Okay, so you learning to develop. So at least initial part. Then the second part of the course, actually, when you go into this SRS documents or this specifications and then design and then testing, there you will go more hand to hand. The theory and the lab will go sort of more in sync, because there we are doing high level stuff. Okay, but initially we thought we will go a little bit into one specific system, which is in case of theory, which is the C++. Does that answer your question?
Yes, understood.
Okay. Any other questions?
Sir, what is the difference between classes and objects?
Okay. So classes are basically types of objects. Okay. So classes, so all of them call it classes, C++, Java, and Python. So classes are, yeah, so they are types of objects. Okay. So the programmer defines the classes. Okay. We will come to classes in 1 or 2 weeks time. Okay. But essentially that is the difference. Okay. So other way of saying it is that objects are instances of classes. So you know, a class can be a cat. Okay, but an instance of a cat, which is a variable in the program, which is of type, the particular of type cat, okay, is an object, or it points to an object or refers to an object, which is, you know, yeah, so which is maybe a particular cat, say C1 or whatever. Okay. And then there can be another cat that you instantiate, which is called C2, and so on and so forth.
Okay, sir.
Okay. Okay. So let us, without any other questions, by the way? Okay. So let us go into the first part of this programming in C++. So we'll call this this part the programming in C++ part, right? So how to develop programs in C++ using object-oriented technique. Okay. So so just to mention here that these slides are taken from NPTEL course that is offered by you know, Professor Parthapratim Das. Okay, so I think he has already given you reference to that course. So of course you can go to that course and also watch things. Okay. Okay. So so the first, or today's objective, is to understand two things. So I'm assuming here that you understand C. Okay, so please stop me if there is something that you don't understand. Okay. Okay. So thinking that you already understand C. Okay. We are going to go into two features of C++. The first one is the storage type modifier. Basically, we will look at const and also volatile, and yeah. And the second thing that we will look at is these inline functions. Okay, so these are the two features we will look at. Okay. Okay. So what is this notion of const? So you know that you can define variables in. By the way, just one thing I should mention about C++ at the very outset is that C++ is a superset of C. Okay, so that is another very big advantage that you have, that if you know C, which all of you know, okay. You can already understand that all the features that are offered by C are also offered by C++. Okay. So for example, I need not tell you what are variables, what are for loops, what are arrays. You know all these things. Okay. Okay. So now you know that C has this concept of variables, which are basically memory locations, and you can store data there. Okay, and the variables can be of many different things. Okay, including that there are types which you can define. Okay, using the structure construct. Okay, or the struct construct in C. And then your variables can be pointing to. I'm using the word object here, but they are not really object in the C++ sense. But let us call them objects just for the sake of it. So you can do that, right? Now. There is this concept. Actually, the concept is there in C also, but we will be focusing on C++. Okay, called the const idea. So what is the const idea? The const idea is that once a particular variable of any type, okay, is declared as const, okay, it cannot be changed. Okay, so throughout the program, it cannot be changed. Okay, so that is the notion of const. Okay, and there are natural constants like pi, e. Okay, then there can be program constants like array size, etc. Okay, now yeah. Okay, so let us. So there is this idea in C called manifest constants. So what are manifest constants? Manifest constants are constants which are defined using this preprocessor directive called hash define. Okay, so you might have used at least one preprocessor directive, which is hash include. Okay, but some of you might have also used this preprocessor directive called hash define. Okay, so what is hash define? So if you look at the program here on the left, okay, hash define TWO2, okay, and space 2. Okay, what this is doing is this is saying that this TWO2 is defined as the number 2. Okay, similarly, the next hash define pi is defined as 4 times arctan, so that is tan inverse 1. Okay, so tan inverse 1 is probably pi by 4. So if you just write 4 times tan inverse 1, that becomes pi. Okay, now here is a program where you are basically computing the perimeter using 2 pi r. Okay, and then you are printing. Okay, so So this is how the program is working. Okay. Now on the right, we show how the program actually works. So what happens is that the C preprocessor, which is also called CPP, okay. So the C preprocessor, it substitutes these manifest constants into the program. Okay, so it processes all the preprocessor directives and creates a modified source program. Okay, so it basically includes the contents of iostream.h and math.h. Okay, and also it takes it wherever in the program it sees this 2 and pi, it just replaces with the corresponding value here. So here you can see it is 2 times 4 arctan1 times r. Okay, that is how it is replaced. And your program will do exactly what is needed to be done. Okay. Okay. Now, so we understand that this constants are necessary in program. Any program needs to have constants. Okay. So the thing that we are trying to determine is it good to use these manifest constants, or is it better to use the const keyword? Okay. Now, how do you use the const keyword? So you basically say const int n is equal to 10. Okay. So here something different has happened. So this n is now a variable. Okay. So that means this variable has a memory location. Okay. But this variable is a constant variable. Okay. So you cannot say something like n is equal to 5. If you say n is equal to 5, it will give you a compilation error. Okay. Okay. So basically what that means that you cannot change the value of n. Okay. You can even try to change the value of n using some indirect methods. Okay. Sometimes you can do, but for example, this particular method will not work. So here, what is the method that we are doing? We are defining a pointer to an integer p. Okay. And then we are copying the address of m in p. And then we are trying to change m by doing an indirection from p. So we are not directly accessing m, but we are accessing m through through its address. Okay, and that will also lead to compilation error. Okay, so you understand the concept of const variables. Okay, now as you can understand,
Sir, this line p equal to ampersand n, will it give the error, or will it give the error if we change it somewhere later?
this will give a compilation error. This line p is equal to ampersand n will give a compilation error.
But sir, we are not changing it now.
No, so see, yeah, so that's a good question. Okay, so so what happens is why this gives a compilation error is that C++ tracks the types. Okay, so it will give a compilation error because you are trying to assign the address of a constant variable to a pointer which is not pointing to a constant variable. So we will come to this, just bear with me. But that is the reason why it will give a compilation error. Is it clear? I mean, I will show you how to actually take the address of a. So from this, you will think that, sir, then can I never take the address of a constant variable? No, you can take the address of a constant variable. Okay. I will come how to take. Understood? Okay. Okay. So okay. So let us go ahead. So Okay, so this is this you can understand that constant variable. I mean, it is natural that you should initialize the constant variable. You can initialize. I mean, it does not make sense to have a constant variable which is not initialized. Okay, so yeah, so that's bad program. Okay, okay. Yeah. So so another example here is that anything can be declared as constant, like I told. So so it's not just the primitive types. You can also declare, for example, you are defining complex here, and complex you can instantiate a variable C which is of type const complex C. Okay. So and then basically sorry, I'm just yeah. So okay. Yeah, so here you can see that C dot RE is equal to 3.5 will again result in a compilation error. Okay, because you are trying to change the component of a const object. Okay. Okay, so so the question is, should we be using should we be using hash define, or should we be using const? Okay, so what happens with hash define is that the compiler does not know the type of 2 or pi. Okay, so if you are using 2 or pi in in some place, okay, and that is leading to, for example, a bug, okay, you cannot see it in a debugger. Okay, of course, needless to say that you cannot take the address of 2 or pi. Okay, whereas using const, okay, you can just do this. Okay, so you can just so both 2 and pi here have so the compiler knows their type. So in the first case it is int, it's a const int type. Okay, and in the second case it's a double type. Okay, now the second question that you may ask is that which one is then going to be more efficient. Okay, so for most modern compilers, both are going to be equally efficient. If not, the second one will be more efficient. Okay, and the reason is that in both cases, okay, uh, your you see, whenever you define const in 2, the compiler knows that this 2 is actually 2, and wherever that pi is actually this 4 arctan pi. So at the compile time itself, it can determine the value of 2 and pi. Okay, and it can substitute it here. Okay, so it is not like because you are defining const double pi is equal to this, that here it will be doing a calculation every time or something like that. Okay, so this is also efficient. Okay, now yeah, so we will yeah, so this is the idea. Okay, yes, any questions?
Can I tell const uses more?
Sorry, can you repeat?
Sir, am I audible?
Yes, yes.
Sir, can I tell const uses more memory than hash define?
Can you
Here we are declaring a variable and it needs some memory.
so are you saying that const is using more memory? Sorry, did someone get the question? Can someone repeat the question for me?
Sir, am I audible?
Yes, yes, you are audible, but only partly. Yeah. Tell.
Sir, can I tell const uses more memory than hash define?
Okay, okay. So const uses more memory. Yes, in the sense that you know, your okay. So let us think about it this way. Okay. So const declares a variable. Okay. So that variable uses memory. Okay. So that is true. Okay. Now here it declares a constant. Okay, so there's a constant 2. Okay, so it's like you are substituting the constant 2 here. Okay, but that 2 also has to be stored somewhere in the program. Okay, so uh, so what I would say to this is that it depends. Sometimes const will use more memory, but it is not like if you are using manifest constants, those constants also have to be stored somewhere in memory. May not be a variable, but somewhere they have to be stored. Okay, so it is not clear that one uses much more memory than the other. So in practice, what you will see is that the total memory is roughly the same. Does that answer your question?
Yes, sir.
Sir, when we do hash define 2, so and then later if we somewhere do like cout 2 by 3, so will it print 0 or will it print 0.666?
That is a very good question. Okay, so but we will do type conversion at a later stage. Okay, so basically what you are saying is, so it will do exactly the same as if you had said cout 2 by 3. Understood? So what would cout 2 by 3 do? Okay, so I think you know from your C programming or something that so by default 2 will be taken as a integer integer constant, right? So 2 by 3 will be, and 3 will also be taken as an integer constant. So 2 by 3 will be taken as an integer division operation, and so it will give 0. Okay, unless
Okay,
you basically cast. Okay. Okay.
Sir,
Yes.
sir, when we do hash define, so the replacement is done during pre-processing, right?
Replacement is done during preprocessing. Yes.
And when we use const, so that is done during runtime. Means it is just like a variable, so that will be done during runtime. Or
Yeah. So during runtime, there is no replacement. See, it is just a variable. So
so when is the value of pi computed? Like
right. So see, um, ideally, um, uh, ideally, what will happen is that if the compiler does not do any optimization, the value of pi will be computed once this statement is executed. Okay. So when is this statement executed? This statement is executed when this variable pi is defined. Okay. This is even before main. Okay. So this is a global variable. So at the time when this variable pi is defined, then the value of pi will be computed. Okay. Now what the compiler does is it can do this thing called constant folding. Okay, so it can do an optimization, and it can understand at compile time compile time itself that this value is a constant value which is known at compile time. So 4 arctan of 1 is a constant value which is known at compile time, and it can do the computation and put it in pi at compile time only. Okay, but this is an optimization, not necessarily that it will be done this way. So it depends on the implementation of the compiler.
okay, sir. But in case of hash define, it will just replace the second string as it is.
Yes.
Okay, sir. Okay.
Okay.
Yes, sir.
So Okay, yeah. So what are the advantages of const? Okay, so yeah, so you can use natural const to declare natural constants like pi, e, phi, etc. Okay, so these are constants which you can compute, you can declare. You can also declare something like true as 1, false as 0. Okay. By the way, you must have used this capital NULL null as a null pointer sometimes, right? So again, this is actually a manifest constant. Okay. So this is defined in standard C header file. I think either stdio or stdlib, one of the two. Okay. So yeah, so and that is sometimes used heavily in C, as you know. Okay. And then of course you can also define program constants like array size, number of elements, etc. And then you can define, you can use these constants to yeah, to define arrays, etc. Okay, so these constants are yeah, so they are known at compile time. Okay, so hence you can define arrays using this. Clear? Okay. Okay. Yeah. So hash define is not type safe. Okay. So just a comparison. It is replaced textually by C preprocessor, cannot be watched in a debugger, and evaluated as many times as replaced. Okay. Whereas the const variable, okay, it has a type, it is visible to the compiler, can be watched in a debugger, and evaluated only on initialization. Okay. Okay. So I think we will stop here and we will go into constant pointers in the next class. Any questions?
So where you will upload these slides?
Yes, so I'm uploading the slides both in Moodle and in the course web page. Okay, so yesterday's slide is already up. I will upload today's slide.
Sir,
Yes.
can you explain the meaning it is not visible to the debugger? Like it is not means like it cannot be catched by debugger. God.
No, it is not even visible to the debugger. See, it is not a variable. So what does the debugger track, right? So the debugger tracks the variables. Okay. And it is not a variable. It's a, so what happens? It is textually replaced in the program. Okay. Let me just show you this program maybe. So can you see this program? This right hand side program. Okay. So this left hand side program, there was 2 and pi. But the program that the compiler sees is actually this right hand side program. Okay. So there is no 2 or pi in the program that the compiler sees. Okay. And hence there is nothing. I mean, the debugger doesn't even know the existence of this 2 and pi. Does this answer the question?
Yes, sir, but on compiling, if we get an error, we can rectify it there and there. Like we can get the idea that this particular error is there.
Okay, so you are talking about compilation errors. Yes, so you can manually determine that, this compilation error. By the way, the compiler error will, so I'll come to some of those in future, but even the compiler error will not say 2 undefined or something like that. Okay, so the error message given by the compiler will also not say something like TWO is not defined or something like that. It will not say. I mean, it will not give, it will not use this TWO in any error message. Okay, but you can manually determine that, this is the reason why I have made a mistake. Okay, but I mean, so another way of thinking about it is that if you want to understand a little bit in the detail, this TWO is not in the symbol table of the compiler. Okay, so the compiler maintains a table of all the names or all the symbols, all the variables that you're defining. Okay, so in there, this TW is not even present. Okay, so you can manually, of course, determine, but the compiler or the debugger, I don't know if you know about this debugger, like something like GDB. Have you used while debugging C programs?
No, sir, not much.
Okay, possibly not. Okay, so there is something called a debugger also. Okay, so what happens is you can compile a C program or a C++ program using the debugging flags. Okay, and if you do that, you can use the GDB to simulate the run of the program. So you can run the program step by step, and you can see and observe the values of each of the variables and so on and so forth. Okay, so you can do that. So you should try this. Okay, so when you are debugging a very critical piece of code, okay, sometimes it is very, very useful. Okay. So anyway, so that is what I meant here when I said that cannot be watched in a debugger. So the debugger there is actually the GDB program or GNU debugger program that I'm talking about. Okay. Does that answer the question?
Yes, sir.
Okay. Okay. Anybody else? I see that Ketan Gupta has raised their hand. So do you have a question or? Okay. Yeah. So if I don't see any questions or comments in the chat also. So okay then. Thank you everyone. So tomorrow again we continue our discussion.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, is debugger in our course?
Thank you, sir.
Thank you, sir.
Debugger as such, I don't
Thank
plan
you, sir.
to cover. But we can discuss maybe in the lab class. Just ask me. We can discuss a little bit. I can just demonstrate a little bit the debugger thing. Okay.
Okay, thank you, sir.
Okay. Okay. Thank you very much. Bye.